All right, so let's talk about number lines. Number lines, more about number lines. Number lines are very useful things, okay? And we're going to show a real world example. Well, it's probably not a very, well, it's a real world example. Maybe kind of silly, but the application is pretty good. The application is good, I should say. The application is good. Let's be a little bit silly, a little bit fun, so we have fun doing it. Okay, so I got my number line right here, okay? Okay, on my elevation of, my number at 0, at negative 50, and at positive 1,000. All right, and I'm actually going to turn it back so it's facing right side up. Okay, so all I've done is I've taken my number line and I've rotated it so that it went from being horizontal to vertical. Okay, horizontal to vertical. Okay. And now I'm going to draw a little bit of a profile of a mountain and a valley and the ocean. Okay. Okay. And typically when we're discussing elevation, sea level, the ocean, sea level, mean sea level, is considered to be 0. Okay, 0 elevation. And then anything above it is positive, and anything below it is going to be negative. All right. So we have an ocean, we have a mountain, we have a little valley here, okay? And we're going to have a sailboat, okay? We're going to have a sailboat. Here is the sailboat. Okay. Here it is, and here's the mast. Here's the front sail, and there's the back sail, okay? There's a little sailboat there. And the captain of the boat, we'll call him Joe. It's a nice day. It's a beautiful mountain. So Joe casts out his anchor. And he goes ashore and he climbs the top of this mountain. Okay, here's Joe. Joe is on the top of this mountain. Okay, I'm on top of the world. Everything is fine, good, and dandy until Joe notices that there is a giant squid right by his boat. I mean, we don't like giant squids by our boat. But there it is. It's a giant squid right by his boat. And obviously, Joe, he's quite frightened. Joe is quite frightened there. And so he whips out his cell phone. Okay. But in his great excitement, Joe fumbles his cell phone and starts tumbling down the mountainside. And after 300 feet, it comes to a stop on the side of the mountain. Okay. It falls 300 feet in elevation and it stops. What elevation is Joe's phone at? What elevation is Joe's phone at? Okay. Okay. So, the elevation that Joe's phone is at, and typically when we're talking about elevation, actually the variable we will use is Z. Okay. Z is the elevation Joe's phone is at, and it's going to be equal to the elevation he starts at, which is 1,000 feet. Okay. And we're going to subtract the distance his phone falls, which is 300 feet. Z equals 700 feet. So Z is 700 feet above sea level. His phone is 700 feet above sea level. Okay? Now, here comes the question. All right, so we got that so far. So far, so good. Now, Joe's phone is sitting here. And before Joe can actually start walking after his phone and gets over his further surprise that he dropped his phone, a groundhog pops out of his hole, hits his phone, and the phone tumbles all the way down to the bottom of this valley, which is at 50 feet below sea level, or negative 50 feet. Now, if we return our number line back, what we are going to see here, what we're going to see, is obviously we can see intuitively that if we start at 1,000 feet and we travel to 0, we're going to travel 1,000 feet in elevation down. to get to 0, and then another 50 feet to get to the bottom of the valley. So the total distance we're going to have to travel is going to be 1,050 feet. All right? So we're going to set up our equation here. So we expect that answer of 1,050 feet. So, all right. And the question now is, how far in elevation does Joe need to go to get his phone? How far in elevation does Joe need to go to get his phone? All right? And so we're going to do a little bit, it's going to be, we're going to continue using Z, but we're going to use actually a little bit different nomenclature. We're going to use delta Z is going to equal the elevation he is at, which is 1,000 feet, minus the new elevation, which is negative 50 feet. All right? Negative 50 feet. So, okay, we know that minus a negative is then the same thing as adding a positive. All right? Or delta Z equals 1,050 feet. Now you may be asking, why is it that I'm using just plain old Z for this one and delta Z for this one, okay? And really what it comes down to is this value is a point and the first one we're asking what elevation. So we are asking what point on the number line Joe wants to go to, okay? We're asking what part on the number line Joe needs to go to, okay? And it's this point right here, which is 700, okay? Joe needs to go to 700. So in this case, because it's a specific elevation, it's plain old Z. In the bottom one, we're asking how far in elevation. So the difference in elevation, okay? The difference in elevation. And in that case, what we want to know is it's going to be not a point on the number line, but really it's just going to be some quantity. Okay, it's just going to be some quantity. In a certain sense, this number is not even positive or negative. It's just it's an absolute value in some sense. Okay, that helps you understand it better. But basically, this is just this span. This delta Z is the span. Okay, on it. The Z is this number, okay? And so when you're talking about delta, you're talking about just some number in general. When you're talking about the elevation or a specific quantity, you're talking about some point, okay? Some point on the line, positive or negative.